Hi guys, I'm going to continue doing the exercises, right? Let's try another one in here. It'll be the integral from 1 to 2, from 0 to 2. Of the absolute value of 2x minus 1 dx. Okay, now we got a problem here because absolute value functions are not continuous. What is continuous? It's something that in every point of the domain, or every internal point of the domain, okay, let's just say that the domain is like A, B, okay, and you have the point A here, and then you have this, and then you got a point B here. So everything inside, not exactly at A and B, but everything inside this stuff, okay? So less than B and greater than A. Everything inside here is going to have a continuous flow of tangent change. So this is going to be something like that, okay? The tangent is here, then it comes here, then it comes here. It gradually changes. That is a continuous function. Now, absolute value functions are not like that. They're like this. They're like a V, okay? Because there's going to be some x in here. This is x. So there's going to be some x point in here where from here on then, coming from the right to the left, at some point it was supposed to be negative, okay? The y is supposed to be negative, but it's not. Because it's an absolute value, the 2x minus 1 will become negative, but because of the absolute value, it'll be changed to positive, right? It'll be like this. Okay, so you got an abrupt change in here. You have something like that, okay? And then you have something like this. So you can see that over here, you have an abrupt change. At this point exactly, not to the right, not to the left, at this point, what is the tangent? There isn't, okay? There's no limit in here. You got a partial limit coming from the right, which is going to be this, this slope, okay? And you got a partial limit coming from the left, which is going to be this slope. So the slope in here is positive, the slope in here is negative, and at that point, it's not continuous, all right? So it's not differentiable at this point. So let's just say that you got something like this, okay? It's just an example, guys. So you have the x in here, and got the y in here. Well, this is a mess. I'm going to do this in here, okay? So let's just say that you have something like that. So this is the x, and this is the y, okay? So you want the area under the graph from this point all the way to 0. Okay, so you want this, and then you want this. Well, you're going to have to make the integral of a function from here all the way to here, and then from here, from this point all the way to here. You got to break the integration in two, okay? So let's do that now. You can see that the domain is from 0 to 2, okay? Now let's see this. When is 2x minus 1 going to be positive or 0? 2x minus 1 is going to be greater or equal to 0. 2x is going to be greater or equal to 1. X is going to be greater or equal than half. Okay, so for this 2x minus 1 to be greater or equal to 0, x is going to be greater or equal than half. So you see what you have in here is actually two functions, okay? Like that. You're going to have 2x minus 1 for x greater or equal to half. For x less than half, greater or equal to half. Yeah, I know guys, it's a mess. For x less than half, you got to have the negative of this. Because it's not going to be this. If it's just this stuff, then x is going to be negative, or y is going to be negative. You see, let's just put 2 times 1/4, right? Because 1/4 is less than half, minus 1. What are you going to have in here? In here, you're going to have half minus 1, which equals minus half. But can you have a minus half? No, because it's an absolute value function. So this is going to be abruptly changed into half. All right. So it just doesn't work. You cannot just put 2x minus 1 in here. You have to do minus 2x minus 1, which is going to be minus 2x plus 1 of what? X less than half. Because if you do x less than half, not half, x less than half, and plug it in minus 2x plus 1, you're still going to get positive values all the way to 0, right? I'm just caring about 0. Well, also for negative values of x, but we're just worrying about from 0 to 2. So you're going to make an integral from 0 to half of what? Of this function here, minus 2x plus 1, minus 2x plus 1 dx, plus the integral from half all the way to 2 of 2x plus 1 dx. All right? Now, well, let's do this part here. It's going to be laborious, but what the heck. Okay. And you can see that these things are continuous, okay? You go from 0 all the way up to half, and then you go from half all the way up to 2. This continuity is very important too. So let's do that in here. It's going to be minus 2x squared divided by 2. So it's going to be minus x squared, okay, plus x. That's what this is going to be. And this, you do that, it'll be from 0 all the way to half, okay? And then you have a plus in here, and let's do this. So here you're going to have 2x squared divided by 2x squared, right? Plus x. Actually, this is minus, right? It's a minus here. Minus x. From half all the way to 2. Okay, so you see when this one in here, you can just ignore the 0 because when 0 is just going to be minus 0. Okay, so let's put a half in here. This is going to be minus 1 quarter, or 1 divided by 4 plus half. And then you have to do a minus 0, but don't worry about that. And then you have the plus. And now you got 2 squared 4 minus 2, 2. Okay. And then you put a minus. And I think it's kind of important, guys. You do 1 quarter here. Okay. Because it's right. Minus half. All right. So what are you going to have in here? In here you're going to have 1 quarter plus. In here you're going to have minus a quarter, but well, let's do this slowly. Okay. I'm going to put a 4 here. In here I'm going to put a 2. Okay. And now 1 minus 2, that's minus 1 quarter. Plus, because with this minus becomes a plus, so it's 2 plus 1 quarter. So we're going to have to do this 8 divided by 4 plus 1 quarter. Okay. So you have 9 over 4 plus 1, 10 over 4, which equals 5 divided by 2. So that's the end of the exercise. I'm going to show you guys the graph now. This is the graph I'm going to put because it's 5. Okay. There. Okay. So you see, I'm trying to find the cursor here. Okay, so we're integrating this part here, okay, which goes from half. This is half right here. This is 1, this is 2. So we're integrating this part plus this part here. So you can see that the functions are different, right? this function here is just a negative of this function here. This one is 2x minus 1, and this one here is minus 2x plus 1. And that's it, guys. Let's continue. Found the area of the region bounded by the graph y equals 2x squared minus 3x plus 2, the x-axis, and the vertical line 0 and 2. Okay, so it's going to be the integral from 0 to 2, okay, of 2x squared minus 3x plus 2 dx. So it's going to be 2x cubed divided by 3 minus 3x squared divided by 2 plus 2x, okay? And you have to replace going from 0 to 2. Do you have to worry about the 0? No, because if you plug zeros in here, it's just going to be 0 everywhere. So what do we have here? We have 16 over 3 minus 4 times 12 over 2, 6 plus 4. Okay. Minus 6 plus 4 is minus 2. If you want to get these together, you replace this for a 6, and you have 16 minus 6, which is 10 over 3. And this is going to be that. All right. It's this area here. All over here. This thing. Yeah, all the way here. You got here. It's this area that's 10/3. Now this one is interesting. You got a function which equals 3x squared minus 2x, okay? Now it wants the average value of this function on the interval from 1 to 4. So you see there's going to be an area in there, right? And it wants to find the average value of this area. So let's check this out. Just want to see something here, right? Okay. You see, in order to find the average value, you gotta spread whatever you find over the entire domain, okay? Now you want the integral of this. You want the integral of this function from 1 all the way to 4, okay, of f of x. This is going to be equal to, well, in this case it's 3x cubed divided by 3. This is going to be x cubed minus 2x squared divided by 2 minus x squared, right? Okay, so you have that. But this is what you're going to find total, all right? This is what you're going to find total. Let's find this. So it's going to be 4 cubed, which is going to be 64, minus 4 squared, which is 16, minus, now this minus is this one, okay? And you got a 1. After the minus, it's a good thing to open a parenthesis, because you know you're going to have to change the signs of everything. So you got 1 cubed minus 1 squared, which is just 0 in this case. Okay, 1 minus 1, so doesn't matter. Anyway, in here, you're going to have a 48, right? 54, yeah, you're going to have a 48 in here. But you see, that's not the 48, that's not the area that it wants. it's the average value of that area, the arithmetic mean. So you have to divide that by the entire range of the domain. So 4 minus 1 equals 3, and you want to divide this 48 divided by 3, which is 16. This is a visual representation of what just happened. I'll put it in here. Yes, you guys can see it. So you see that you have the... Now, what does this mean? This is very interesting. Okay, so if you're going to check the area, I'm going to put the sticker here. So if you're going to check the area, what is 48? 48 is this whole stuff. Okay? This is 48. Great. Now, the average value is this stuff spread across from 1 to 4, which is a 3 unit. So 48 divided by 3, 16. What does that mean? That means that if you want to transform this area from something curved, from a curved top in here, to a straight top, all you got to do is to make the entire area divided by 3 equally. So it's going to be 16. So what you have is, this is not to scale, right? So this is, you got 3 units in here, and in here you have 16 units. Okay, so this is supposed to be larger, okay? It's actually, if you're going to keep it to scale, it's supposed to be something like that. But this is not to scale, right? Because from this, the distance from here to 1 is 2, and the distance from here to 1 is 10. So you can see that the scale of this is 5 times over the x-axis. So that's what you have, it, guys. You have, it's going to be 3 times 16, that's 48, okay? Now, of course, you can see that the graph in here is squished this way, okay? It's squashed like this. If you're going to make the scale, the thing was going to be a lot larger. It would be something like this, something like that. That would be the graph to scale. On the scale will be like this. On a 1-to-1 proportion between the x-axis and the y-axis. Let's see here, I'm gonna go back. Okay. Now there's some kind of weird notation here that you guys are going to have to see it. It wants to evaluate the integral from 0 all the way to x of cosine of t dt. Now, what is the variable of integration? It's t. Okay, you're integrating this with respect to t. So x is not a variable of integration, it's just an upper limit. So what is this going to be equal to? Well, it's going to be sine of t, right? It's going to be sine of t. Now, you want from 0 all the way to x, so actually it's going to be sine of x minus sine of 0. Now, sine of 0 is 0, okay? And sine of x, you can just give it any value you want. For example, x equals 0, x equals 30 degrees. So for this one, it's going to be 0. For 30 degrees, it's going to be half. Okay. For 45 degrees, it's going to be square root of 2 divided by 2. For 60 degrees, it's going to be square root of 3 divided by 2. Okay. And for 90 degrees, it'll be 1. This is just a trigonometric table here. Okay. Let me think in here. The book does something weird, but fine. I just want to expose you guys to this stuff. Okay, it's asking to find the derivative of f of x, which equals the integral from pi divided by 2 all the way to x cubed cosine of t dt. Okay. Now, you see, you're integrating this stuff. You don't actually have to worry about too much. Well, okay. Anyway, it's asking to find the derivative of f of x. Okay, so you have to differentiate this stuff. But here's the kicker: you're integrating, right? You're integrating cosine of t with dt. So whatever cosine of t dt is, you're going to integrate that. And then you want to find the derivative of that. So you're coming back. So you don't actually have to calculate, all right, so this is for example, what is the integral of this? It's going to be sine, so the derivative is going to be the cosine. No, it's like I'm giving you something to take it away immediately. So it's integrating. So if you're integrating, it's going to, for example, become g of whatever, g of x, right? But then it's asking to find the derivative. From here, it'll come to here, and now it's asking to find a derivative, so it'll go exactly back to where it was, okay? So cosine, you're integrating that, you get something else. Now you want to differentiate it, so differentiate it, all right? Now, when you differentiate it, you're going to have the cosine, okay? But it's not going to be of t. Remember that you have this upper limit here, x cubed, and you're differentiating it with respect to x. So what you're going to have is that you're going to have the cosine of x cubed, because t, right? T is the variable of integration. You integrate it, doesn't matter what it became, you integrate it. And then you put on that formula x cubed minus pi divided by 2. Now, whatever that formula is of pi divided by 2 is going to be a constant. So when you differentiate that part, yeah, I know it's crazy. I'm going to do this to you guys. You're integrating this. So this is going to be g of x cubed minus g of pi divided by 2. Right, now you're going to differentiate this stuff with respect to x. Is asking, that's what it's asking for. Now this has a function of x in here, but this one doesn't. This one is just a constant, okay? So this becomes 0. You don't have to worry about that. Now differentiate this stuff with respect to x. To differentiate, you're coming back to f. Because when you integrate it, you got to g. Differentiating g, you're coming back to f. So it's going to be the cosine of what? X cubed. And then I have to use the chain rule. What is the derivative of x cubed? 3x squared. Okay, so that's the final answer. It's nuts. Let me think in here if I want to do this for you guys now. Okay, yeah, we can do that. Not gonna be too complicated. But after this one, I think I'll take a break. I decided to make smaller videos instead of 1 hour, 1.5 hour videos, maybe. Okay. But anyway, a chemical is flowing into a storage tank at a rate of 180 plus 3t liters per minute. Okay, where the t is going to be greater or equal to 0 and less than or equal to 60. All right, so the thing is going to be flowing, whatever fluid it is going to be flowing into a tank at this rate in here. If this is the rate, you know that this is the derivative. Okay, this is going to be f prime of t equals this. Where the blah blah blah. Okay, so find the amount of the chemical that flows into the tank during the first 20 minutes. So it wants the total amount, because this is just the rate, right? For example, when t equals 0, you're going to have 180 liters per minute. Okay, when t equals 2, you see the flow is actually getting more and more and more. It's increasing. When t equals 2, this is going to be 6. So it's going to be 186 liters per minute. When t equals 3, it's going to be 189, right? So the flow of the chemical into the tank is getting more and more rapid, and it wants to find out the entire flow. So you integrate this with respect to t, which is going to be 180t plus 3t squared divided by 2, okay? And you want the total from 0 minutes to 20 minutes. Well, when you substitute 0 in here, it's going to be 0, so don't worry about that. So you have in the first 20 minutes, it's going to be 18 times 2, 36, but you have 2 extra zeros, so 3,600 plus. And now you see here it's going to be 400 because it's 20 times 20, 400. Divided by 2, 200 times 3, 600. Equals 4,200 liters. Okay, that's how much it's gonna be in the first 20 minutes. That's how much of the chemical, how many liters of the chemical will be in the tank in the first 20 minutes. That's it, guys. I'm gonna stop the video here now.